without further ado, I'd like to introduce the first panel. Our moderator is James Pearce, who does DevRel for Facebook. He tells me that he now spends like about half of his time doing stuff on native, but his first love is still the web. And so it's highly appropriate that he's going to be taking this really crucial session about mobile performance. So,
all right,
take it away, James. Thank you.
All right. Well, welcome everybody. As Sam said, this is the performance panel. I was honored to be invited to come and moderate it. I guess Facebook's recent history with mobile and the web has been relatively well documented. It's, as Michael said, that Zuckerberg quote is the gift that keeps giving. But we have obviously made a commitment on our apps, anyway, on the Facebook apps, to producing the best possible quality experience that we can. And we've ended up rewriting both of our iOS and Android apps to be pure native, where they were previously hybrid HTML5 in a wrapper kind of apps. And if I summarize starkly the decision we made there, it was performance. There was only one reason why we did that. We had to retrain literally hundreds of developers. We had to retool our entire build chain to produce iOS and Android apps where we'd been previously building, a pure web stack. And pixel for pixel, the old web app and the new native apps were indistinguishable. If you put them, not anymore, but if you'd put them side by side at the time, it was very, very difficult to tell which was which. The only way you could tell they were different was the performance. And overnight, pretty much, our ratings in the App Store for the iOS app went from 2 stars to 4 stars. And let me just say again, it was nothing to do with the pixels or the appearance or the rendering or the drop shadows or anything. It was purely the performance and the increased user experience of that. So it was because of mobile web performance that we had to make this incredible investment. And we really didn't want to have to do that. So I'm here mostly to moderate and channel your questions and channel the questions off the moderator here. But also I'm here to say, dude, where's my 60 frames a second? You honestly promised this years ago. The web was going to catch up, but we haven't got it. And businesses like ours and businesses around the world are still struggling with this problem. So I have a panel here of 4 distinguished experts, 2 from the Chrome team and 2 from external companies. I'd like them to introduce themselves. We have Paul, Tom, Ilya, and Ariya. A couple of minutes each, if you would like, just to introduce yourselves, please.
Hey everybody, my name is Paul Bakaus. I'm the WTC rep and CTO for a studio called Studio 5 at Zynga. And we're basically on a mission to build the next generation, what we think is the next generation of social games. And we think HTML5 is the right platform for that. We've been operating in stealth mode for quite a bit, but now we're starting to roll out our first experiments. And lots of them really involve performance with stuff like terms like instant play. We want to make people play the games instantly, and that's where we think HTML5 comes really into play. That's me.
Hi, I'm Tom Wiltzius. I'm a product manager on the Chrome team, sort of working across graphics projects, including Canvas, WebGL, but also just sort of core rendering performance. So I am on the other side of all of this.
Hi everyone, my name is Ilya, so I'm a developer advocate on Make2Fast and Google Chrome teams, and my focus has primarily been on the network side, so specifically for mobile performance, latency, how do we accelerate that, so HTTP2s, speedy, and just trying to figure out what we can do to move the web forward and to enable richer apps that are still efficient when delivered over the web.
Hi everyone, my name is Ariya. I work for Sencha. We produce frameworks, tools, and cloud services for web application, both desktop and mobile. I have a general interest in web technologies. I've been mainly the native guy for a very long time. I worked on WebKit when I was with Nokia, and then 2.5 years ago, I decided to switch side and try to find out how painful or comfortable it is working with front-end development.
So Now that you know who everybody is, that's a great opportunity for you to think of the hardest question you'd like to ask each of them. Hopefully you all have the moderator page up so you can ask them there, or simply raise your hand. But to get started with, I thought, I was thinking about this. I mean, mobile performance is, there's no one thing that contributes to performance, right? It's a blend of lots of different disciplines, and we expect developers to be masters of all of them in order to produce highly performant apps. Sometimes it's going to be, the GPU that's the impact or the major effect on their performance. Sometimes it's going to be the network performance. Sometimes it's going to be, JavaScript runtime or whatever. So, given that the average developer is looking at this huge surface area of problem that they have to solve, where should they start first? What are the major performance pain points that you see from your own points of view? I guess we'll start at this end and go down again. So.
Okay, so I think it depends on what you're building really, but I think if you're building web apps and websites, it's mostly about load time performance. I would see load time performance being the biggest bottleneck right now. There's been recent studies that e-commerce sites have been degrading in terms of performance, I think over 40% or something. And that's very, very worrying to me. And on mobile, it's even worse. If the website loads in over 10 seconds, most people drop off. And of course, it's not entirely the fault of the website and the browser. It's also network performance, network latencies. But I think that's an area where we should focus on first. With games, as longer lived the sessions are for your app or for your game, the more you have to focus obviously on runtime performance, memory management, all sorts of stuff. But I would start with load time.
I suppose I'm a bit biased in that I work on rendering performance, so that's probably what I'm going to say is the most important thing. But I do think that we are moving to this world where people expect a lot more out of web applications, right? And we're sort of moving from this world of e-commerce sites and the like, right, which are strongly rooted in the tradition of the web as sort of document viewer, and we're moving much more towards applications where we expect real-time performance, et cetera. And I'll kind of call out James's point earlier about needing to retrain this entire core of Facebook developers to do native mobile app development and how painful that was. But I think it's in some ways unrealistic to expect that the same sort of developer skill set that applied to building kind of the old generation of web applications, which were very rooted in, again, like a document viewer type model, it's unrealistic to expect that skill set to cleanly apply to an application that you're expecting to do something very different, right? Like when you're expecting 60 frames a second and complicated UI animations and transitions, you're building a different beast. It's going to require a different set of skills. So I think the entire community does need to sort of prepare for and expect appropriately that a lot of re-education is going to be required.
Yeah, so I'll second, so I work on networks, so I'm also biased. But I'll second what Paul was saying, but I'll also add a few more things, which is there's obviously the first experience when you first load the page, and then there's the rest of the experience, which is your app is loaded, and then the frames per second and everything matters. So it's not a question of either or, and I would say if the question is where do you start, I would actually say it's neither one of these three. So we have, internally we've been talking about render, compute, and network, right? Those are the three pillars of performance. And the moment you fix one, you're on to the next, and then you unlock the next bottleneck. So the place to start is to actually invest into analytics to figure out where is my problem to begin with. It's not a question of I know rendering, so I'm going to focus on rendering. It's well, if your bottleneck is compute, that's where you should start. So in the network world, at least, we've put a lot of effort into developing tools like real user measurement, right? Such that you can gather real data from real users on real hardware, and then figure out that, hey, no, it really is a problem on 3G, for example, for my users to download these apps. And I know you guys have done a lot of work to figure out how to get the games down in sub 3 seconds or even sub 1 second, right? Yeah. And that's a really interesting challenge. Yeah.
And I'll also say that's an area where we are way behind on the rendering side of things. Your ability to measure in-field anything about how your rendering performance is it's really hard to the point where you sort of can't do it. And I think that's the kind of thing we've talked about, for instance, in like the web performance working group about what we might be able to do about that. But I think we're not really closing in on a solution yet, largely because implementations vary so wildly. So if anyone has bright ideas about what they would like to see from sort of a field analytics API for rendering, I'd love to hear it.
So in my opinion, evangelism is one thing that we need to work better. We need to come up with better vocabulary to the developers. Those who work in the front-end development space, they probably never studied computer science. So if I'm being given the task by my manager to build the mobile side of the company, and then suddenly I need to know everything from GPU compositing to JavaScript just-in-time compiler, garbage collector, this is all, another thingy magic. This is all scary stuff. So that's one thing that we need to work more. And another thing is also to give the understanding that performance is not only about optimizing the transport, meaning that the bits and pieces from the server to the client. With the rise of single-page application, your apps might run for a while. So, for example, if you build an address book and sorting a context, 10 contexts is 10 milliseconds, it doesn't mean that it will scale nicely if you use bubble sort. So scalability is also important with respect to performance and not only time measurement.
So it sounds to me like there are lots of individual technical things we need to think about here as well, but there is an overall cultural issue, right? Which is that developers who think the web is something they can just lash up in a text editor are now being dropped into a very different world, where they're being expected to use tools with 40 character long command lines and huge big log spews that they have to visualize and so forth. So we can come back to some of the technology, but I'm intrigued by this because there's a tooling piece here, right, which is going to make it a lot easier for people, and there's best practice around how they should instrument their apps, both at presumably develop time, but also at runtime. Maybe the two of you could talk a little bit about what's happening on Chrome, and then we're going to talk about some other browsers too, if you don't mind. So just give us a quick rundown on tools and education and instrumentation as it pertains to Chrome.
Sure. Want to kick it off?
Sure. So for network, I'll highlight one, which is actually cross-browser, which is real user measurement, right? So this is a new API that is relatively new. It's supported by all the modern browsers, where when the page loads, you can actually query to say, give me all the timestamps for the sequence of the loading of the page. So anything from TCP connection time to there was a redirect to this how much time it took to load, etc. And the cool thing about this is once you have this data, this is from a real user on a real device on a real network. You can beacon it back to your analytics, aggregate it, and then segment it in a bazillion different ways and actually run meaningful A/B experiments, right? You can actually figure out that this connection took this long, so forth, and so forth. So this alone I think has changed the network performance conversation in a dramatic way, right? Now that we can gather this data. We need something like that for GPU. And maybe it's as simple as sampling this data and beaconing back via a similar mechanism.
Yeah, and that's definitely the kind of thing, again, we're sort of interested in trying to explore, but it is challenging because the notion, people ask for things well, I just want how many frames a second am I getting, right? And that's actually not a meaningful question to ask, because in sort of a multi-threaded browser, you can have 1 to 4 answers to this question, and you get a different number of answers depending on what browser you're running in. So from sort of a sort of cross-browser tooling or analytics perspective, I think rendering is kind of one of the toughest because it's one of the areas where the browsers have evolved most differently. But I think we are moving towards a world where a combination of some of the CSS features that have been spec'd and sort of the performance needs of the platform are forcing a slow reconvergence of how a lot of these things work. So I'm cautiously optimistic that in the future we'll be able to instrument some of these things better. Sorry, go ahead.
So for Chrome DevTools, we've put in a lot of effort into instrumenting all the right bits of the stack so that you can get at the root of the problem. But I think the one challenge that we have today is still you still need a lot of education to know what to look for. Right? It's you need to run the trace, and then you're looking at this waterfall, and you need training. Like I know that when I sit down with somebody like with yourself or Paul, and I see you guys go through the whole workflow, I'm like, oh, there's 5 tricks I was never aware of, just because I've never thought about it. So what we can do, I think, a better job of is actually giving these kind of insights to developers to say, here's an anti-pattern, like let's flag it, let's put a red flag beside it, right, and have a learn more link. This is the culture piece, right? Like we need to educate people about what these things are. I think we've done a fairly good job on the network side because we've been tackling that problem for longer. Yeah. Rendering and other things, we have a lot of room for improvement.
Well, I just wanted to say one big issue I think with rendering performance, measuring rendering performance, is because harder to isolate it on the actual device. Because it might be entirely the user's fault why rendering is down. You might have lots of apps open that do something in the background and that consume memory, and then textures keep swapping from memory spaces, and that's something that I think is fairly difficult, because if you get reports in from the same device, let's say a Nexus device, but to completely randomize, it's very hard to kind of construct data out of that. I think that's a real challenge.
I think that's to a certain extent that is a challenge with network performance as well, though, right? Because it's entirely possible that some app is swamping my kind of local. Yeah, exactly. It's sort of the nature of a shared resource, right? I do think, though, to get back to your original question about kind of like what are some of the best tools available, at least in Chrome, for debugging rendering performance, compared to where we were maybe a year ago, we do have some features that are relatively simple and incremental, but you get a lot of mileage out of them. These are things like the vertical timeline. We have kind of re-architected the way sort of our paint rectangle visibility feature works to work with sort of the latest actual under the hood rendering pipeline. We have a mode that continuously repaints the entire page, which helps you diagnose what is taking a long time to paint. These are relatively simple things, but they can actually go a pretty long way in debugging sites. And I know I was talking to Paul Lewis, one of our other developer advocates, just before this talk, about people who were coming by earlier at the Chrome sort of perf alley thing over at Moscone, and I think often weren't aware that this was a big problem, or weren't aware of like how they would even begin to start addressing this. But with a little bit of education about how to use these tools, actually came away with a lot of things that they could go then sort of investigate on their own. So I think, yes, that is cultural, yes, that is educational, and I think we're starting to have some better tools in this space, but for the really hard cases, we're still not there.
Related to the performance and tools, we also need to educate developers to include performance metrics as part of their development workflow. For example, you build a fantastic game, you build nice scroller, nice apps, and it scrolls beautifully, and then suddenly some intern, junior engineer, whoever, checking some code, probably has good intention, but the performance drops from 60 frames per second to 30, and there's no way to detect that.
So can I add just one thing? So prior to focusing on, I guess, network performance, I was actually part of the Google Analytics team, so there's my another bias. Performance is a feature, right? When we talk about performance drops, your conversion drops, your engagement drops, we have good measurements, as you mentioned before, where like conversions drop by 4%. There's not many features you can add to an e-commerce site that will bump your revenue per user by 4%, right? So it is a feature like any other. It should be prioritized on your backlog like any other. It's not a sprint that you do at the end to clean up your app. It's like, I'm going to build this thing and then I'm going to fix performance. It's like you can't slap on performance just like you can't slap on security at the end, right? So invest early into measuring this stuff. Like how does this actually translate to my users? I think this is a very, very important metric.
All right, I want to do a little straw poll here if possible. How many people here in the audience so if you're developing for mobile and you're developing for the mobile web, if you find a performance problem, do you know what to do? I mean, do you feel like you have all the tools you need to be able to go and diagnose it? Do you feel you have the understanding about network, GPU, especially in the mobile case, to go and solve that? I mean, who feels that they are totally tooled up and ready to go cross-browser, cross-device? Nobody. Okay. So, I mean, there's obviously work to be done. But I think the cross-browser thing is important, and I know this is predominantly a Chrome session, but I think, oh, it's Dion. Dion, where are you? You have a question, which I think is to do with other browsers. Would you like to stand up and ask?
Hi, Dion Almair, Walmart Labs. And so you set up that question very nicely.
I'm wondering whether AV is easier or harder than web performance at this point.
It's wired. They should have wireless.
Hey. So we have that exact pain point. Like the Chrome developer tools are amazing. There's good developer tools across other browsers and that like that. But I watch, all the developers on the team, coming up with this problem on some ancient, Android browser that's being used by someone in the UK or some BlackBerry user or someone else. And they have to go and relearn a different tool for everything. It's like, the equivalent that we've joked about before, where you've, Friends is really successful on TV, and then you got to make the DVD and you got to recast everyone and film it again from scratch, right? It just is so painful. And then you get the Sony mini disc version that just has your buddies in it. So is there any help coming there?
I mean, to a certain extent, this is a pretty difficult thing you're asking for, right? Because like the point of many independent but interoperable implementations of web browsers is that the implementations are different, right? So if what you really want is like visibility into the guts of the thing, which is I think often what people ask for, then that's tough. I think honestly the real hope is that is twofold. One, the performance pain points that are kind of most obvious and most easy to stumble on will be ironed out over time as those kind of real legacy browsers go away and the kind of modern browsers care a lot more and compete with each other to try to stay performant, right? And then from sort of like a standardization perspective, we get like very good APIs defined and everyone sticks to them, right? We're doing a lot of work to make sure that, especially in a world with Blink, another rendering engine, we stay as interoperable as possible when it comes to spec compliance, but people don't spec performance, right? So what we're relying on to make sure performance is just good is competition between browsers. I think that's healthy. I think that's going to work. And hopefully that will kind of push the performance ceiling or floor, depending on how you look at it, to a point where you don't need to worry as much about huge differences, like these cliffs existing only in some browsers but not in others. And we'll get to only things that are fundamentally, because of the specification or something, too slow. And then we can have conversations about how we can improve them by changing the APIs.
So Paul, I'm guessing you probably have a fairly large surface area that you're looking to deal with, and you also have very high, I mean, you do have perf specs, right? You do know what frames a second you have to get to.
That's right.
Like to share those with us?
I mean, well, first of all, I wanted to say that I think it's, regarding the specs, I think it's super odd that performance is not part of spec. And I've been talking about this on the WTC level a lot. And what's weird is that in most other standards bodies, performance is actually part of the spec. So, in the LTE spec, for instance, performance is a large part of it. And I find it super odd that it's not being done on the WTC level. So that's first. And so on the product side, we're also taking performance very seriously from the start and adding it to the spec. So, I mean, we'd like to be at 60 FPS for runtime performance, sure. We have goals to stay below 3 seconds for load time, at least on Wi-Fi and LTE. If you're on a 3G connection, all bets are off, because even just activating the radio signal to the next cell can take up to, I don't know, a couple seconds. So at that point, you don't have much influence over it. But yes, I think the point about regression is, that Ariya mentioned is a good point, because if you have it in the spec really early, performance metrics for your features, what you want to build, you start thinking about differently. And with every commit, you continue measuring if it degraded your performance or not, whether you're still on track. And I think that's what's super important. Not specifically whether you're looking for to have your app load in 3 or 5 seconds, but really just making sure you have a spec.
And what do you do, and what is your sort of target device portfolio? I mean, do you set the floor at a particular version of a particular browser? And by the way, I'm interested, what do you do for users that happen to have an inappropriately poor device?
So right now, I'm happy to say that the stuff we're building right now is, has a fairly large set of browser support. So for instance, on Android, we're targeting Gingerbread and up, which is, as you know, I mean, if you've worked with Android and mobile performance, Gingerbread is quite a challenge because it only has the stock browser. And well, I'm not sure if you can install Chrome Mobile on Gingerbread. I don't think you can.
You can install Opera.
You can install Opera, yeah, but not many people do it, I think. At least that's my guess. I don't have data on it. Sorry about that. But yeah, it's a real challenge. That being said, I also think there's a place to build games and apps that push the edge. So I think we should be. I just wrote a blog post about this actually. Like I was arguing that many managers really think HTML5 in particular as a performance issue. I don't think that's fair. I think no user complains. Well, some do, but I argue it's stupid. But usual users don't complain that their latest PC game doesn't run well on their 10-year-old Windows XP computer. But people do with HTML5. Like I see managers trying to load apps in IE8 on bad hardware and complaining about it, and that has to stop. That's just not fair, and I think we need to push it more.
So we can also view it from a different perspective. How many of you here have heard about Robo Hornet? Oh, good. So the idea behind this benchmark is to come up with a common set bearing any standard performance metrics from the standard bodies that can be run in all browsers. And that should be, if you get the buy-in from the browser vendors, for example, inserting 1,000 rows on a table should not get slower as the browser gets new release. For example, IE12 should not be slower compared to IE11 or IE10 with respect to doing that kind of stuff. So if that is part of the development workflow from the browser vendor themselves, then they know for sure that, hey, if I degrade this performance, then some real-world application like Google Apps or frameworks like Sanchata, jQuery Mobile, they will have a performance impact.
So getting back to the kind of the tooling question across different platforms, I think we have some good answers for the network side. So for example, we have open source project like web page test, right? Which allow you to run a test against different browsers, so IE, Chrome, and the rest, and get the same visual output. And that is already a great start, right? Because I know DevTools really, really well, but I haven't been using IE tools for a while. So at least now you can put them side by side and say, here's A, here's B, and now I can compare the waterfalls and compare that, right? And we've developed basically kind of bottom-up specs for that. So HTTP archive spec, where you can right-click on the waterfall and export it and import it into a different tool. We have an export for the timeline in Chrome, right? But we don't have a tool like, it would be cool if you could export a rendering timeline from Firefox and also have a similar tool where you could compare them and say, like, I'm getting X FPS here and Y FPS over there. That's all doable, I think.
Yeah, again, modulo the fact that like people ask for FPS, not realizing that this is a difficult thing to really standardize what that term even means. But your point's absolutely a good one, and actually I'll tie that to what we were saying about kind of like measuring performance regressions. Yep. We have a framework, I guess I'd call it, that we've used to monitor Chrome performance as we develop Chrome. It's called Telemetry. It's something you can go check out. We have some documentation on the Chromium dev site if you're interested. But basically, it's a Python harness that talks to Chrome via the Chrome Developer Tools protocol and instructs it to do simple things like load a page, scroll it, get a bunch of stats back out. But these are implementation specific stats, which is painful. But then we can monitor for like scrolling performance regressions, for instance. And if people like external developers want to plug their own content into this and keep the version of Chrome fixed but iterate on that content.
Yeah.
I think could be a useful tool for
so
that.
I think what we can do to make that better is make it simpler, right? So
Yeah, and then make it work across browsers.
Like the beauty
Yeah.
of web page tests is I come to a web page, I type in literally the name of the page,
Yeah.
and I just say IE 10, right, or IE 9, and I'm
Mhm.
done. Right now to run telemetry, it's like,
it's
check out
complicated. Yeah.
Chromium and just build it. It's like,
Yeah.
and then there's the fact
It
that
does
it's a
work
4 gig
with
checkout.
Yeah, I mean, it does work with sort of stock Chrome binary, but yeah, your point's a good one. And I wonder how we can make this work. I don't know if we need to get buy-in from other browser vendors or what, how we can make this work with other browsers. Like we need a standard way of communicating sort of from outside the browser.
Yep.
And
So we actually have a related question on the moderator here, which is from Andre Behrens here. Nope. Yes? Would you like to come up and ask it regarding Chrome performance versus... You're on record, so...
Yeah, my question was simply why, I have a pretty heavy app that I work on, why is the performance on certain things quick as the dickens on an iPad currently and not on a Nexus 10? Like, are they cheating? Is there a hardware cheat, or is it just enough time, or like where are the slowdowns at? Because I notice them sometimes. It's a lot better, but I notice them.
you're talking about rendering performance, I assume?
Yes.
Or like what, do you have specific operations in mind?
The one that really gets me is like touch response and rendering after the touch response.
Mm-hmm.
And I'm doing a big, heavy, nasty thing with it. I'm moving a lot of DOM nodes around, but like on the Pixel, it's really great. On my computer, it's really great. On the iPad, it's really great. On most Android devices, it's pretty good. And I'm wondering like what the difference is.
Yeah, I mean, so some of this is a resource question, right? I love the comparison between iPads and iPhones and Android devices because it shows we're in the same league, even though they're half the price. But I do think that it remains a challenge for us to make good on all those sort of performance promises of that comparison, right? So to a certain extent, we kind of have our work cut out for us there. But it is something we're working on very hard, and hopefully we'll just sort of get better underneath you as time goes on. The latest versions of Chrome for Android, which is to say those that have come out in the last like few months, have actually a radically different rendering architecture than the ones that came out, say, like at this time last year at I/O 2012. And we're going to continue making changes at almost that big a pace. So right now, one of the things we're looking at, for instance, is what can we do about input latency, which is kind of, it's probably not the exact silver bullet for your problem, but it's very much related, right? And part of Chrome's very complicated multi-process architecture is that we do a lot of thread hopping, and this is really hurting performance when it comes to input latency. This is something we're looking at revamping right now. So our hope is a lot of this will get better. I don't think there's anything kind of fundamental here.
Okay.
I do want to point out one other thing, though, which is also that it's a lot, I don't want to make excuses, but it is a lot more challenging to change things that are so related to things like touch input because they need to work across, we work across 5 operating systems, not one. And that's a major challenge.
Okay. We're actually a little pushed for time. Time flies when you're having fun. But I did have one final question, and then we're going to go around with a conclusion, which is perhaps related. I'm not sure if it's a GPU issue or a networking issue, but I have a very specific question from Charles Ying, which is, are there any efforts in place to optimize the power consumption of Chrome right now? I mean, this is something that web developers have never really thought about before, but now they do have to.
I can speak to this unless you want to.
So I'm curious about the do have to. Do you have a good example in mind? Is that something that you guys optimize for?
Well, I mean, on the assumption that people spend 25% of their time on smartphones on Facebook, I suppose we have a responsibility to make sure it's not using up their batteries too much. Yeah. But I would imagine the same goes for games, right? I mean, you don't want to be the, quote, app that is responsible for killing someone's battery in a day.
Yeah. So I think maybe a year ago we were we were just talking before this panel, talking about FPS in a browser was kind of like a new concept for a lot of people. I think talking about battery life today in a browser is a new concept for a lot of people, because what do you mean, right? Like, I'm just rendering a web page. That is not the case, because we're building apps, and these apps are running for a long time. They have memory leaks, they have other things. On networking side, there are lots of great examples where we're doing things wrong today. Things like, let me just slap on a real-time analytics beacon on my page, because it's awesome, right? I get a nice vanity dashboard that shows me the number of people on my site, and then every 5 seconds you're pinging the radio and just burning the freaking battery on the device, right? Those are good examples of where we need to fix these patterns. I think we need to educate developers. We need to educate the companies that are building these things. Like Google Analytics actually addressed this about a year ago, but I've done a recent survey of other real-time analytics. They're all doing the same problem.
Yeah, I think, to be perfectly honest, from a rendering standpoint, we are so bottlenecked on sort of core performance right now that power consumption, while we definitely worry about it, it's kind of lower on our hierarchy of worries. And the reason is that as we improve performance, we're only going to improve power consumption, right? So right now, to scroll a web page in Chrome for Android on sort of an older generation Nexus device, say like a Nexus S or something. Yeah, Greg, you wanna say something? Burns all your CPU, which burns all your power.
Yeah, we do
so
care a lot about power, and we're actually working right now on making changes to our telemetry, which is a Python framework for running tests on Chrome Desktop, Chrome OS, Chrome on Android. So we're working on making changes to it to actually measure power. Sorry, I am Greg Simon. I work with the Blink team and others.
So in some cases, it also needs some cooperation from the hardware vendor. For example, Qualcomm has a very nice profiler, can't remember the name, but that gives you the exact measurement of the consumption from the radio to the GPU. And that's very important metric, right? Because if I build my game using WebGL and then suddenly it burns more power than as if it will have written with native OpenGLES, then that's not a good proposition.
Yep. And just to add to that, one thing I'd love to see as part of either DevTools or any sort of tool chain is, for example, visibility into the radio, right? Paul, you mentioned that sometimes just turning on the radio takes literally seconds and burns a lot of battery. Having understanding and visibility into how the radio operates can have a huge impact. We don't have any instrumentation across any platform. Even the native apps don't really have good instrumentation. Like I was looking, so Qualcomm is a great example. AT&T actually has a great tool. There's basically no other tool where you can actually record a session on your phone, and then it'll model. It's not an exact measurement, but it'll model the radio states and the actual battery consumption. Like it'll tell you this app consumed X many joules of energy, right? And that's a start.
Cool. We have time, I think, for one question from the floor. Robert?
So we're talking about actual performance and real numbers and what we can do to improve things, but we're also talking about education. Do you think we should put more time into educating people about perceived performance? Like, because we only have certain limits that we have right now, like 3G, etc. So should we talk more about sort of not fallbacks, but different angles of how to make things better for users without building new devices?
Oh yeah, I would say absolutely. Yeah, I think that's a great point. As internally at Zynga, we always think about actual performance and perceived performance, responsiveness, and that starts with easy stuff. Like if you click a button, make it do something while you're waiting, right? Or if you're loading your page, show a loader, do something, right? Put something out to the user so there's that anxiety of waiting isn't perceived the same way. And there's all kinds of techniques to do that. And I think it's important to educate people about those. Yeah.
In the interest of getting one more question in, I'm going to hand over. Did you want a question? No, I wants to answer the power question. Unless anyone has any more on that previous point. Go ahead.
So I'm Grace Klober. I'm the tech lead for the Chrome for Android. So I think to answer the power question is Android actually does have the tools to measure the power and very precise the tools they call, and then the device called a Manson device. They basically replace the battery on the phone and then measure on the per amp base for all the actions. And then they publish all the open source how to hook up the tools with Android platform. So you can, if you have a web app, you can run the apps and then to monitor what action can trigger it. So as a developer, I will suggest the things is try to not put a lot of like a timer, especially just because on the mobile device is when CPU is running in the high frequency, it's burning a lot of battery. And for the multi-core devices, sometimes they keep one core working, but if the CPU workload is higher, they're going to bring up more cores. So the more core means more power usage. And then they have this way is basically after a couple of milliseconds, no activity, they're going to crank down the power. But if you keep like every, like say, 2 seconds and then you fire a timer yourself and then try to check something in the background and then nothing happens, you sleep. But the device is going to run in, basically keep running in this high power mode and then basically going to burn the battery. And also things for like for the radio things is every time one radio is taking a little bit longer time to bring up, and then they normally keep it in the longer times. And for the another case is, for example, is Wi-Fi. So probably people having device with a Wi-Fi this week experience the bad battery life in the Moscone Center, because Wi-Fi is bad, so device keep try to connect to the Wi-Fi, and then that also burn the batteries. So.
2 minutes? Got 2 minutes left? All right. Okay. We started late. We're using up time. So if we could just quickly go around. I have 2 questions. You have 30 seconds to answer 2 questions each. And the first question is, if I'm an average web developer and I want to take away something that I can start doing right now to make my web apps more performant, what would that one thing be? And secondly, if you could cast a magic spell to make mobile web performance a better place, assuming you had the power of the Google Chrome team, for example, what would that one thing be? Go ahead, 30 seconds each.
Okay, so first thing, I'm going to give you an actionable item on actual improving the perceived responsiveness of your app, but also saving your battery life. And that is anytime the app doesn't have anything to do. For instance, if your app needs a login flow, right? So you started a login, username, password input. At that time, do a big network burst to load all your data in the background. Because after the user logs in, he will have all the stuff loaded already. I mean, the chance is very likely he'll load it. He doesn't quit the app before logging in. So that's a great point in which should be loading data.
And the one thing you would fix if you could?
The one thing I would fix is, let's see, scrolling. Yeah, give us good scrolling APIs on Chrome mobile. Yes. APIs. I want APIs, yeah. Microsoft has them, Chrome doesn't.
All right.
I guess my one takeaway would be that you should be aware that jank is a problem, and it's a hard problem to solve, but we do have some tools to solve it, and I would encourage you to check out a lot of our sort of developer relations resources on how to use Chrome's dev tools to fight that jank. I gave a talk about this yesterday, but even basic tools like show paint rectangles or show composite layer borders or the vertical timeline goes really far.
And you are the fairy godmother, so what is the one thing you can fix for everybody?
Yeah, right. It's a good question. I mean, I guess I was going to phrase my answer somewhat differently because I wasn't going to fix something. I was going to change the way a lot of the web's specifications were built so that we're not stuck in such complicated scenarios.
That counts. Go ahead.
There are a lot of things that we would like to be able to do that sort of we're a little bit hemmed in by the immense, expansive API service of the web. So I am happy that on mobile we've been able to move a little bit faster. I want us to be able to move a little bit faster everywhere. I think one of the ways we're going to do that without actually causing pain by changing things is by introducing new primitives into the web that are going to allow us to have the pit of awesome, right? The things that are only going to be fast, but you're going to be able to do less inside of them. We have ideas around, for instance, like infinite list containers, right, that are just going to work. And you won't be able to have like crazy overhanging floats, but it'll be fast and that'll be good.
Infinite list controllers in a pit of awesome. Yeah. Can we have that by tomorrow?
Sure.
Thank you. Ilya?
Let's see. So maybe coming back to perceived performance, I think it's a really good point, and coming back to education as well. I think developers should learn about the radio and how it works, this mobile radio thing, because we keep complaining about mobile networks being slow, unpredictable, so much latency, variability. Once you actually learn how the basics of those things work, like you probably need to spend a couple of hours just reading about how it works, you can actually model most of these high latency environments really, really well. Anticipate them, and then you very quickly realize that an average thing, like an average request over 3G will take a second. That directly tells you something about how you design your application, right? How you structure, how your UI works, and all the rest.
Magic wish?
Magic wish, faster than speed of light traveled, because that would solve all of our latency problems. Right? That network performance solved, but I don't think we're going to get that. Yeah.
All right, well, never mind.
So like what Ilya said, treat performance as a feature, automate performance measurement, put it as part of your development workflow, CI system, whatever, even if it's just a simple smoke test. Create a git pre-commit hook that blocks the check-in if something gets slower.
All right,
and magic wish? So more parallelism. So the Samsung Galaxy S4 International Edition has this 8-core CPU, a big little architecture. So I think we're gonna see probably 16-core mobile CPU in the near future. So more parallelism in the browser will be very awesome.
All right, that's it. We're over. That's a wrap. Thank you, everyone.